This is part 3 video on drag force experiment. Here we are going to look into the graphical representation of the experimental data. There is as such no calculation involved here. The objective is verification of the theoretical concepts, which is drag force directly proportional to the object's cross-sectional area and drag force proportional to the flow velocity. These two are the objectives. We are going to verify it by means of some experimental measurements. So the data that you have collected will be filled in this table, after which you are going to plot two graphs. First is drag force on y-axis, pressure on x-axis. Second graph, drag force on y-axis and velocity on x-axis. So F versus V, F versus P, and you are going to plot the data for all the three disks, 40, 56 and 80. So you will get three curves for each of these two graphs that you will make. Let's try to look into the data table to get the data for pressure versus force. So pressure readings that you have on the first column, that goes on x-axis, then F1 data goes on y-axis, then same pressure on x-axis, F2 data, then same pressure on x-axis, F3 data. That way you will be able to come up with this graph. Then the second graph, force versus velocity. Velocity will be on x-axis, so you have velocity as second column here. So we always fix that on x-axis, and V versus F1 on y-axis, that is first curve. Then velocity versus F2, you get second curve. Velocity versus F3, you get the third curve. So that is the second graph, that you have three curves, velocity versus force. Once you do this, you will be able to conclude that the drag force is proportional to area. Any disk you are going to choose, you select randomly any pressure and you go along that pressure vertically upwards. You will find that the highest drag force is for the 80 mm diameter disk, which has the biggest cross-sectional area. So that verifies the first objective, drag force is proportional to the area. And for the second objective, force proportional to velocity, we are increasing the velocity from, let's say, 0 to let's say 10 meter per second, and any disk you select, you observe the drag force to be increasing with increase in velocity. The curve is an upward going curve. So whether it is 56 mm or 80 mm, all three disks give you the same behavior. The force is increasing with increase in velocity, so that verifies your objective number 2. So that is all about graphs involved with this experiment. There is no calculation to be done here as per the objective.